Hi everyone. So today we're going to be going over another inclined plane question. So this one involves a pulling force, some friction, and acceleration. So let's get started. So the question is, you're pulling a box of very important physics textbooks up an incline of 40 degrees with 150 Newton force. There's 6 of them and each weigh 3 kilograms. If the acceleration is 0.4 meters per second squared up the incline, calculate the mu of friction and the force you need to pull in order to have no acceleration. All right, so just like any other question, let's start up with the setup. So let's draw a diagram of what's happening. So you have a box right here, and you can have yourself just pulling up that box of textbooks. Okay, and then the incline over here is, of course, 40. So next thing we want to do is to draw a free body diagram of the forces acting on this box of physics books. So you have Fg and then Fn. Then you have the pulling force acting this way. And because you are accelerating up the incline, friction, of course, is going to oppose that motion, so it's going to be pointing down. I'll try to squeeze that in. There. So let's go ahead and draw a vector addition diagram of this. So you have the force of gravity going straight down. Then you can draw Fn like this. Then let's draw the friction force like that. And then you have the pulling force that's going to start right here and go all the way up past the Fg vector. And this is because we need to draw the F net vector, which is connected to here all the way. And then it hits the tail of the head of the F pull vector. Like that, and it connects right there. And then, of course, the angle over here corresponds to this angle right here. All right, so we're done with the setup. So let's go ahead and start to solve for the mu of friction in the first question. Okay, so note that once we have everything set up like this in a vector addition diagram, whatever component we're trying to find of the triangle or the shape just becomes a pure math problem. So right now what we need to find is this vector over here. So if we come up with an expression that includes this vector over here, we can solve for its components, which has mu in them. So first, let's note that F pull over here, we can write it as being equal to the friction vector plus the F net vector plus this midsection right here, which is part of this triangle. And remember that this triangle over here, just this section, still creates a right angled triangle. So let's just call this midsection here A. Okay, so F pull, we can rewrite it as the force of friction plus A, and let's go ahead and solve for what actually A is. So note that A is opposite to this angle, and Fg, of course, is the hypotenuse, and Fn is the adjacent side. So we could write sine of 40 is equal to A over Fg. And solving for that, that just gives you Fg sine 40 is equal to A. So we can just plug that right here. So this gives us Fg sine theta plus F net, which is this component. So once again, F pull is equal to this section here, right, which is F of friction, and it's equal to this right here, which is A, which we get as Fg sine theta plus F net. All right, so let's go ahead and solve for mu. So first, let's break down its components. So F pull is just F pull. So we can't do anything there. Friction is just mu times Fn. And remember from before, Fn is equal to mg cos theta. So what we get is mg cos theta plus FG is equal to mg sine theta, and then F net is just equal to m times a. So let's go ahead and move all of the components over and isolate for m. So what we get is F pull minus all of this, right? So we get mg sine theta minus ma is equal to mu mg cos theta. And next thing we want to do is just divide by mg cos theta on both sides. So then we can just isolate for mu. So if I can rewrite this as mu is going to be equal to F pull minus mg sine theta minus ma all over mg cos theta. All right, so now all we need to do is plug in the numbers into here because we know all of their values and solve for mu. So F pull is equal to 150 newtons minus m, which is, so there's 6 books and each of them weigh 3 kilograms. So the total mass, I'll just write it here, is just going to be 6 times 3 kilograms. So it's going to be equal to 18 kilograms is their total mass. So that's going to be 18. I'm just going to avoid taking up too much space, I'm going to just write the number rather than the units. So 18 times 9.8 sine theta minus 18 times the acceleration 0.4 all over 18 times 9.8 times cos theta. And the value I get is, oh, I notice I didn't put the 40 in here, so I'll just put that. Okay, so the value I get is 0.2176. I'm just going to round it to 0.128 as being equal to mu. All right, so the only tricky part of this question is coming up with this diagram over here. You have to notice that the acceleration is going up the incline, so you have to extend this F pull vector all the way past the beginning of the FG vector in order for you to show that the acceleration is going up the incline like that. All right, so let's go ahead and start solving the second question. So this one's saying if there is no F net, so no acceleration, what does F pull have to be? All right, so all the forces are still the same. The vector of addition diagram is the only thing that's different. So this component here is just cut off. So our diagram is going to look like this. So you have Fg, Fn, F of friction, and then F pull is just going to join up with Fg. So just like before, we're going to be writing F pull is going to be equal to F of friction plus this mid component here, which we calculated last time. So this is going to be equal to F pull is equal to mg sine theta plus the force of friction. So let's go ahead and just break down it into its components. So you have, this is just mg sine theta, of course, plus friction, which is mu times Fn, which is mg cos theta. And we know all these values, and we have mu from the last question. So let's go ahead and just plug in these values. So you get 18 kilograms times 9.8 meters per second squared times sine, what is it, 40? Yep. And then plus 0.218, 18 kilograms, I'm running out of room, 9.8 meters per second squared times cos 40, yeah, sorry about that. So let me go ahead and calculate this. Okay, so what I get is 142.846, and I'm just going to round it to 0.85. So that is the pulling force that you need in order to have no acceleration. All right, so thank you once again for watching. If you have any questions, leave them in the comments below. And if you also want me to work out some other physics questions, leave them in the comments below as well. Thank you.